Hi, this is David from Electric Teaching, and we are continuing part 2 of our trapezoid approximation in our calculus section here of my video lessons. So I've done part 1 where I've really tried to give an explanation of left end and right end, and we even did the sum sequence trick on the calculator to accelerate the process of adding up the heights or summing up the sequence of heights. And before we dive in and do the program for the trap formula, I want to just review and make sure we've got a clear understanding of how the left end and right ends work with the trap. If the left end is basically a delta x, that's the b minus a, up here b minus a over n, times, in this case, I'm going to use this one as a specific example. Okay, the left end was f of 1 plus f of 1.5. The delta is a half, so the next plug and chug is a half, plus the f of 2, and then plus the f of 2.5. This is jumping by the delta of 0.5, and this is summing up the heights. The reason we don't add in f of 3 is because that is the right end of one of those rectangles that we would build in the Riemann sums. In case you didn't realize, I am talking about Riemann sums here. So the right end is also a delta x, but it doesn't start at f of 1. It starts at f of 1.5, and then goes to f of 2, and then goes to f of 2.5, and then it has an f of 3. That might be off the video. Sorry about that. So what I wanted to show you is if you literally add these two, factor the delta x out, that's the b minus a over n again. If you factor the delta x out of these two terms added and then collect, you can see we're going to have, clearly, we're going to have 2 of the f 1.5s and 2 of the f of 2s and 2 of the f of 2.5s. So you can see then the middle terms are plugged in twice. That's why the trap formula has the 2 on each one of the middle ones. So I can use the left end and the right end sums to get the trap. If I add these two to get the average, I'm going to divide by 2. So that's, again, I've mentioned that earlier, why we have that extra divide by 2 on there. And then the formula is, as you might see in books, the f of a plus 2 times all the middle ones, and then at the end, f of b. But that is basically, I am taking my left end plus my right end stuff. That's all I'm going to do. So that's how I'm going to trick, or basically write a snazzy little program that'll give me not only the left end sums, but the right end sums. On your calculator, okay, we want to, if I can turn it on there, okay, I'm going to go to Program button. I'm going to go to the Program button. Now, I have many programs in here. I do a lot of programming on my TI for my advanced algebra classes and stuff. You may not have any programs in here. Don't worry about having nothing on this list. If you have just these 3 headers, that's fine. Let's start a new, right arrow, new, create a new program. Okay, I'm going to call this calc sums or approximate sums. I can call it anything I want. I used to always call this trap sums, but since I'm doing both the left end and the right end, I thought it'd be neat to do, call it something, not neat, but appropriate to call it something different. This means it's locked on alpha, so that means all my colored letters and text items like quote and the space right there, that's all locked down. I'm in alpha lock mode, so I can just go ahead and type up, and like I said, I'm going to name it maybe calc sums, C-A-L-C-S-U-M. So I've noticed that it's a hard time finding these letters. I'm a little bit more apt at it because I've done it before. So if you have trouble, literally hit pause on the video right now and finish typing up calc sum. All right, hit enter. When you hit enter, you're going to get an instruction line here. This is the first line of code. Most programs, almost all programs, are basically input, some input of information, calculations, and then output. Even games on your iPhone and on your Android system, even all those games are basically comes down to simple ideas of bringing information in, running calculations, and kicking information out. Sometimes it's just displaying information. We're going to do some number crunching, as I like to do, some programming that's number crunching. First thing I'd like to do is go Program button. I'm finding the Program button here. Program. Okay, notice it's different. When I'm starting a new program, the header's different. When I'm in the program, it gives me all the programming attributes, all the programming elements. I have if statements, which we won't use in this one, but I've used in other programs. For loops, while loops. I'm going to go right arrow. That stands for input output. I'm going to select prompt. I've only seen the command prompt in the TI programming world. I've never really seen it in any other programming language. We usually use an input. But prompt is very user-friendly, so let's use it. What are we prompting? Well, we need to tell it after we figure out what the function is, and I'll talk about how we're going to work the function itself, like log x cubed. But we need to tell it from where to where. So we're going to tell it from 1 to 3 and making n equal 4. So 4 different rectangles. So we need to prompt the A, the B, and the N so we know those values. So we actually type in prompt, as we've done, alpha A. It's alpha A. Comma's right above the 7. Hit comma. Alpha B. Comma again above the 7. And alpha N. Alpha N. That'll be for the number of triangles. Hit enter. We're going to first calculate the delta x, So to get this calculation, I'm going to run the calculation first, and then I'm going to store it in a new variable. That'll make a little more sense in a second. Parentheses, alpha b minus alpha a. You have to have parentheses for the entire numerator, basic PEMDAS stuff. PEMDAS is in order of operations. Divided by n, alpha n. So I'm going to hit the alpha and then find the n button. Down here is the store button. This is the assigning variable, to be technically correct here. This is the assigning variable button. It's called store. It puts a little arrow up there. And we're going to store this, I think, appropriately into the variable d for delta. Hit enter. One instruction per line is usually the rule with coding. So now I'm on the next line of instruction. I'm going to do the sum sequence trick to get the left end height sum. So I'm basically going to use the left end heights, and I call them heights because they're the heights of the rectangles that we're plugging and chugging to get. So I'm going to do the sum of the heights, the sum sequence trick with the sum of the heights for the left end. So again, if we didn't see part 1 of the video, I go second list, that's the stat button, go all the way over to math. If I hit 5, it'll jump down to the sum. So hit 5 or go down arrow and hit enter. Now the sequence, it's in list again, right arrow, 5th one down, so I'm going to hit 5, sequence. Sum sequence. To run the program, I don't want to have to always go in and edit the program and type in the actual function log x cubed. So what I'm going to do is I'm going to actually put it in, I'm going to make it into the y equal button. I'm actually later going to put y equal in the y equal button, the log x cubed. So in here, I need the program to find the variable, the vars, that's what that stands for, the y variable, that's the right arrow, and function will list y1 for me, in fact, all the y's. So if I hit enter on y1, it's going to say, it's going to sum up whatever the function is in y1, comma, it takes 5 elements here. So y1, comma, and if you're on the TI-84, I know you're on a different screen, so just keep putting these 5 elements in the 5 fields you see. Okay? You might be on a different screen, depends on the version. y1, we have to tell it that we're going to use x, so make sure we use x when we go to assign the function, the actual name of the function, comma. With left ends, we start at a. See how it starts at f of 1 here? That was the first point. We actually start at alpha a. But I'm using a variable so that I can run it from any point to any point. We're not going to end. You remember we don't end at 3 on this one. We ended at the 2.5. So using variables, you're not ending at b, you're ending at b minus a delta. 1 delta back, 1 rectangle width back, 1 delta back. I might be over-explaining things, but I'd rather you have a thorough understanding if you're writing code. Then we need to jump by d's, alpha d. We need to jump by d's. I'm going to close parentheses for the sequence. I'm going to close parentheses for the sum. I'm going to hit the store button. I'm going to store this into a variable, I don't know, L sounds pretty appropriate. Let's use alpha L. So now I've got the left end sums, the heights summed up, ready to go, and it's in an L variable. To actually get the left end approximation in a few minutes here, I'm going to multiply L times the D and display that answer. So let's hit enter. And now, before I get to displaying the approximation for the left ends, I want to get the right end sums as well. I want to do both these sum sequence simultaneously. So I'm going to go through that a little faster here because I'm not teaching as much. Go into second list, go over to math, go to number 5, that's sum. Second stat button or second list, right arrow, fifth one down, sequence. The Y1 is in vars, right arrow, enter, get the Y1 in there. Comma, we still are using X as the variable that's incrementing. Comma, we are not starting on A for the right end. We're starting on A plus a delta. Kind of like we were ending on B minus a delta. We're actually starting on A plus a delta. That'll give us a starting point of the right endpoint. Comma, I'm still in, now this one I actually end at B. I actually do plug and chug the B, not B minus D like before, but I actually, alpha B. I actually end at the B, alpha B. I'm still jumping by alpha D. I'm still jumping by deltas. Close parentheses twice, store alpha, I think R would be appropriate for the right end heights. This isn't the right ends, this is just the right end heights all summed up, plugged and chugged in a sense. Hit enter. Let's display now. Let's display program, right arrow, input output stuff, display, third one down. Now I'm going to make this look a little pro here. So actually, no, first I'm going to just display the answers and then I'll come back and we'll edit it to make it look a little pro. Not totally pro, but just a little bit better, a little more informative. So I'm going to display the left end and right end points right now. I'm going to display the left end. Let's just try displaying the left end and right end, and we'll do trap in a second here. So to display, if I say display left, L, that's just the heights. I need to do L times D. It's one of the few programming languages where you put two variables next to each other and it knows the algebra is multiplying. If you do this in C++ and other languages, it won't work. JavaScript won't work. You have to use the star or the time symbol, so keep that in mind. I'm going to hit enter. I'm also going to display, so I'm going to go to program. I'm also, right arrow, display, going to display the right end sum, alpha R, times the delta. Hopefully you're anticipating times D because you're starting to make sense of this. Now let's run the program. Let's run this program. We found earlier, see my numbers right here, 1.13 and 2.03. Those were the left end and right end points. Those are the left and right end points. So if I run the program, here's how we run it. You quit the program, that's second quit. So you quit the program, there's no save button. Sorry, there's no edit undo, there's no save. It's kind of not the best environment for programming, but it at least is something that you have this instrument usually handy in high school, so it's a great tool to dabble with programming, let's say. If I click on program, I'm going to find my new program here called CalcSum. Yours may be the only one in here. I have several other programs. So I found CalcSum. The header up here is execute, so I'm going to hit enter to execute CalcSum. When it comes up on the screen, okay, when it comes up on the screen, I'm going to hit enter again. But I just realized something. I realized that I don't have Y1 with the program. Remember, I got to put Y1 with the function log x cube. So before I hit enter here, I'm going to leave the screen. It'll come back to it in a second. I'm going to go to Y1. I'm going to clear out whatever's in my Y1. On that note, make sure there's no plots highlighted too. It's always safer. And I'm going to put in log x caret 3, log of x cubed. Now I've got a Y1. I don't care if Y2 has anything. I'm not using Y2. So I'm going to go second, quit. Notice I'm right back where I was, so it's waiting for me. And just so you know, when you bring up a program to the screen, it's asking, do you want to run the program? Yes, I do. Hit enter. So if you hit enter, which I just did, sorry you didn't see that. If I hit enter, it's saying, oh, what's your A? Well, we're running it from A equal 1 to B equal 3. So I'm going to go 1, enter, 3 for B, enter, and our first estimate was 4 rectangles. 4 rectangles. And it kicks out 2 answers, 1.13, recognize it, and 2.028, or rounded to 2.03, recognize it. Let's edit this and let's add just a little bit more info so that we can understand this down the road, and let's add in the trap. The trap's not too hard. The formula's basically right down here. We're looking at it. Okay, so let's go back to program. I'm going to go edit, and then I'm going to come down to my calc sum. If it's the top one, just hit enter, and now I'm in edit mode. Be careful. If you hit buttons that you're not sure of, you may clear it or delete things, so be really careful. Okay, I want to insert in a little text here. It'll only take a second. I'm going to go second INS. It'll allow me to insert in here. I'm going to insert. I'm going to insert some text that I want to lock down the alpha. If I hit second alpha, I'm going to get the blinking A, which means I'm locked on alpha. Anything in quotes is considered a string. That's just a fancy programming word for a bunch of characters off the keyboard. So a string of text is what we'll say. So anything in quotes will just be, we'll throw the screen of text onto the screen. Excuse me, the string of text onto the screen. So I'm going to just type in something real quick to remind me, down the road what this is. I'm going to type LE colon. There's actually a colon down here as a character, colon. And I'm going to hit close quote, and then I'm going to put a comma. So it's going to say LE, comma didn't work because I was on alpha lock. Hit the alpha button, then hit comma over that letter I just did. So it's going to say LE, it's going to throw this on the screen because it's in quotes, and then it's going to do this calculation and throw that number on the screen afterwards. Same idea, we should probably insert, okay, alpha lock, quote, RE, right endpoints, if you didn't figure out what the E stands for, right endpoints, okay, quote, close quote, and then get rid of the alpha lock by hitting alpha and put a comma in. And now I've got it so it'll display that right endpoints is this calculation. Okay, go down arrow until you're at the bottom. I think it'll take you to the right side of that last line. Hit enter, program, input, output, display. We are now going to display the trap. Let's go ahead and make this look a little more professional, or just a little more informative. Let's put trap, just the word trap. It'll make sense down the road then. I'm having trouble seeing the letters here. Trap. Okay, colon, quote, knock the alpha off, comma, and now we need to put the calculation, and you can kind of see it right here. It's my delta x times left E plus right E divided by 2. Not the full left ends. In fact, technically this is a little bit wrong. It's technically just the L's and the R's that I'm adding up, not the full delta x. I'm pulling the delta x's out, so not the full left and right ends. So it's just the LR variables that we've been playing with. So my trap is simply the delta multiplied, okay, times parentheses L alpha L plus alpha R. Alpha R. I'm trying to find R. There it is. Close parentheses, divide by 2. That's the average of them. The average of the L heights, which is really kind of based off, you can see it right here, the average of how you get the area of trapezoids. Let's run the program. To run the program, you quit. And since it's the last thing I've done, the last thing I did was run the program. If you hit enter again without going to find it, it's still thinking it's in the program mode. It's still running my program. So if I hit enter again, it's going, cool, what's your A? I'm going to go 1 again. I'm going to go 3 again. And then I'm going to say 4 again. Now, pretty much we know the LE and the RE were right. Notice the trap is between these areas. Remember, these are areas, approximate areas. So we've got a situation here where we can do investigation. We can actually watch, which I think sometimes is more important than doing the algebra and the plugging and chugging of all this stuff. We can use our program to watch what happens when we run the program again from 1 to 3, and we can talk about what happens as we increase our n's to maybe 20 n's. What we should see is the numbers should get closer and closer to each other. The left n and the right n should be getting closer to each other, and dead center between them should be the trap. And we can keep doing this again and again until we actually see one of the more exact answers. I'll do it one more time. Okay, so I'm going to do it from 1 to 3, and I'm actually going to do maybe 100 trapezoids. So these numbers should be pretty close together. As long as I didn't overload the computer, that's a lot of calculations, and it kicks out. It does it great. So 1.67 for the left, 1.7 for the right. You can see there's still some space between these two, and the closer approximation is 1.68829. Don't forget, you can actually get, and you might think about this, the way the calculator does, I don't know if you know this, second trace button, second calc, the way the calculator does integrals, well, it might be our trap approximation. It might be our trap approximation of our graph. Oh, I got two graphs on there. Please forgive me. I got that second graph on there. But it could give us the approximation. That might be how it's doing it. So I'm going to double check the answer the calculator gets. So it's running from lower limit 1, enter, to 3, enter, and it'll fill the area, and look, it's 1.68832, which wasn't too far off where we were, 1.688 rounding 3. You can see that. So this is probably how the calculator runs its program. Not positive on it. You can actually email Texas Instruments if you're curious. This is 2 long videos, I apologize, but I hope that I have given you some insight on not only the trap, but the Riemann sums, and how to use programming to really accelerate the learning moment. I'm hoping teachers will be interested in teaching this to their class as well. Of course, it's still important to do it by hand, but it's also important to learn the programming aspects and be able to talk about the calculus as much as you do practicing the calculus algebra. I'm David from Electric Teaching, and I hope that I have helped.